Good morning,
Good
sir.
morning,
Good
sir.
morning.
Good morning, sir.
Good morning, sir.
Morning,
Good
sir.
morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning,
Today
sir.
we will discuss Taylor's
Good morning,
theorem.
sir.
Okay, is it invisible?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Taylor's theorem with Lagrange's form of remainder. Taylor's theorem Taylor's theorem with Lagrange's form of remainder. Suppose or let f be a real valued function. A real valued function with or having n plus 1 continuous derivative. So function must have n plus 1th derivative, and that must be continuous. In the interval AB, where n is greater or equal to 0, let x0 be any point belonging to AB. Then for any x belongs to AB, fx can be written as fx equal to f of x0 plus x minus x0 by factorial 1 f dash x0 plus x minus x0 square by factorial 2 f dash double dash x0 and so on. X minus x0 to the power n by factorial n fn x0, fn x0 means nth derivative, plus x minus x0 to the power n plus 1 by factorial n plus 1 f n plus 1, that means n plus 1 is derivative at the point C, where C is a point that belongs to x0 to x. x0 to C belongs to x0 to x. So there are two terms from here to here, one part, and this part is the second part. This series is called nth Taylor's expansion of fx at x0. So fx can be written as, so fx equal to fx0 plus x minus x0 by factorial 1 f dash x0 plus x minus x0 squared by factorial 2 f double dash x0, and dot dot dot. The last term is x minus x0 to the power n by factorial n f nth derivative at the point x0 plus these terms. Now we can rewrite this equation as fx equal to pnx plus rn plus 1 x. But pnx is what? This expression from here to here. This expression is pnx, and the last term concerning the point C is called the remainder or error term. So pnx is the nth Taylor polynomial of fx at x0 and rn plus 1 x. This is x minus x0 to the power n plus 1 by factorial n plus 1 f n plus 1 c is called remainder of the Taylor's expansion after n plus 1 term. There are before this expression there are n plus 1. Before this expression there are n plus 1 terms. So this is the remainder of Taylor's expansion after n plus 1 term. Now suppose we put x0 equal to a and x equal to a plus h. That means in this interval a plus h, where a equal to x0 and this is x, where h is a number greater than 0. Then any point between a and a plus h can be written as a plus theta into h, but theta belongs to 0 to 1. Any point between a and a plus h can be written as a plus theta h, but theta is between 0 and 1. Then the above expression, that is Taylor series expansion, can be written as there was f of x, that is a plus h, is equal to f of a plus h f dash a, for h x minus x0, that is a plus h minus a, that is h f dash plus h square by factorial dot dot dot. This will be h to the power n factorial n fn a plus the last term is h n plus 1 by factorial n plus 1 if n plus 1 is derivative, and the c, any point c, we right here any point c will be of the form a plus theta h, so there a plus theta h, right? Any confusion or any queries?
So you have written that in the last line h raised to power n by factorial n. After that, you have multiplied it with function raised to power n a, or it is the n time derivative of the function.
Derivative,
It's the n time derivative of the function, right?
n times derivative. Okay, this is actually n times derivative. Now, no. Suppose the function fx is a polynomial of degree m. Of degree m, then if r x, where if r means rth order derivative of fx equal to what when r greater than m? It will
0.
be 0
0.
for all r greater than m. That means the remainder term r n plus 1x will be 0 for all n greater equal to m. Greater equal to why? Because n plus n greater than m. In that case, fx will be equal to fx0 plus x minus x0 by factorial 1 f dash x0 plus x minus x0 square by factorial 2 f double dash x0 and x minus x0 to the power m by factorial m fmx0 plus x minus x0 to the power m plus 1 by factorial m plus 1 f m plus 1 x0 and so on. But these terms after the m plus 1 term actually, these are the total m plus 1 term. After m plus 1 term, all the remaining term will be equal to 0, right? Because derivative of m plus 1, one order derivative will be all equal to 0. So this there are m plus 1, then m plus 2 and so on, right? Not audible. Hello.
Hello, audible, sir.
Now second case, not 2. Suppose x0 equal to a.
Sir, sir, x naught x minus x naught power n plus 1. In this situation, how it is 0?
Because
How
f
it
is a
becomes?
function, we already, f is a polynomial of degree m.
Yes, sir.
So in that case, derivative of m plus 1 and so on, our higher order derivatives will be all equal to 0.
Yes, sir. I got
Okay.
it.
Now in second note 2, when x is equal to a and x equal to b and n equal to 0 in a particular case, then f of, we have f of x equal to f of x0 plus x minus x0 by x minus x0 f dash x0 x minus x0 square by factorial 2 f double dash x0 and so on. And in that case, this will be fx, that means f of b, and f of x0, that is f of a, plus x minus x0, that is b minus a, f dash x0 means a, plus x minus x0 square by factorial 2 and into f double dash x0. These terms will be 0 because we take n equal to 0. So remainder term n plus 1, that is r1. R1 is x minus, we have to take n equal to 1. N equal to 1. That in that case, x minus x0 square by factorial 2 f double dash x0 will be equal to 0. So this is, no, okay, wait, n will be 0, n will be 0. N will be 0. When n equal to 0, the remainder term is r n equal to 0. Remainder term r n plus 1, that is r 0 plus 1, that is r1. R1 is x minus x0 by factorial 1 f dash x0. So there is not x0, it will be c. So x minus x0 by factorial 1 f dash c. So in that case, FB will be equal to f of A plus the remainder term. Remainder term 0 plus 1, that is FA x minus x0, that is DL1 f
Sir,
dash
your
C.
voice is
F
cracking.
dash C is equal to actually f of B minus f of A. So f dash C is equal to fb minus fa by b minus a. So this is the form of Lagrange's mean value theorem. This is the Lagrange's mean value theorem. So we can consider the mean value theorem, that is Lagrange's mean value theorem, is a special case. Is a special case of Taylor's theorem.
Sir,
Ah,
sir, 1 equal to 0 means f of 1. The function is only one time continuous derivative.
please say loudly.
If n equal to 0 means what is the meaning, sir? Means the function is only one time continuous derivative or 0 times continuous derivative.
N equal to 0 means if we put here, right? Yeah.
Only one time
Yeah.
continuous.
Sound is problem. Say again.
Sir, now we should write that term also, no, sir. B minus a into f dash of a. One time derivative, no, sir.
Not audible. I can't hear your voice. Say again.
Now,
Sir, this function is already defined.
continuous derivative, no, sir.
Ah,
So now we should write the first term b minus a into f dash of a. Then after that all other becomes 0, no, sir.
if you
Before
take
remainder,
wait, if you take n equal to 0, the remainder term will be R1. Okay. So what is the R1? R1, that means Rn plus 1. If we put n equal to 0, then R1 will be remainder. So what will be the R1? R1 is just put the formula x minus x0 to the power n. Put n equal to 0.
okay, sir.
So x minus x0 to the power n plus 1 f n plus 1 c. So put n equal to 0 here there. So x minus x0, right, Rn plus 1. Okay. This is x minus x0 to the power n plus 1 by factorial n plus 1 f n plus 1 c. Now n equal to 0, that is R1. R1 is x minus x0 to the power 1 by factorial 1 f1 c. This is the remainder. In that case, fb equal to fa plus R1. So R1 is
B minus a by
b minus a by factorial 1
f dash
F
of c.
dash
dash
C.
c, right?
Yes, sir.
So f dash c will be fb minus f of a by
B minus.
b minus a. This is a special, actually Lagrange's mean value theorem. So Lagrange's mean value theorem we get from Taylor's series, Taylor's theorem. So this is Lagrange's mean value theorem is a special case of Taylor's theorem. Okay. Now, example 1. Expand f of x by f of x equal to x to the power 4 minus 5x cube plus 5x square plus in fx will be just formula
You are
f2
not.
plus x minus 2 by factorial 1 f dash 2
Sir,
ah,
so what did you said after 5x square?
5x square plus x plus 2.
So write on the board, sir.
Sir, the
It is
screen
stop.
is
Screen is
Screen
paused.
paused. Yes, sir.
Not
yes,
visible.
sir. The
Screen
screen is
paused.
paused. Yes,
No,
sir. Not visible.
it is visible,
Yes,
but the
yes, sir.
screen, but the screen is not
Paused.
stuck, or you can flutter.
Okay. Now screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So we have to expand fx equal to x to the power 4 minus 5x cube plus 5x square plus x plus 2 in the power of x minus 2. That is, fx has to be expanded by Taylor series at the point x equal to 2. Now, what is the formula? By Taylor series fx equal to f2 plus x minus 2 by factorial 1 f dash 2 plus x minus 2 square by factorial 2 f double dash 2 plus x minus 2 cube by factorial 3 f32 plus x minus 2 4 by factorial 4 f4 2, and the other terms that contains f5 2 f6 2 all are will be equal to 0 because f is a function of f is a polynomial of order 4, so all other all term will be equal to 0. Now we have to find f dash x, f double dash x, f triple dash x, and f4x. So f dash x will be 4x cube minus 5x square 15x square plus 10x plus 1. F double dash x 12x square minus 30x plus 10. F triple dash, this will be 24x minus 30. This will be 24, and f5 f6 all are equal to 0. Now f dash at the point 2, f double dash at the point 2, f triple dash at the point 2, and f4 dash at the point 2. What will be the value? Just put x equal to 2 here, and we get f dash 2 equal to minus 7. This is minus 2. This is 18, and this is 24. Huh?
24.
Okay.
Yes,
Now
sir.
just replace these values. So fx will be minus 7 plus x minus 2 by factorial 1, that is 1, f double dash, that is minus 2, plus x minus 2 square by factorial 2 f double dash 2, that is
Sir, f of 2 is not
Yes,
minus
sir.
7.
F dash 2
Minus
is
7 should be multiplied with x minus 2.
X minus 2.
Okay, okay, okay. Okay, there's mistakes. So f of 2 what? F of 2 is
0.
0. So that is 0 plus.
0.
F of 2 is equal to 0.
Okay. So this will be now x minus 2 plus x minus 2 square by factorial 2, and this will be, what is f double dash 2 minus 2 plus x minus 2 cube by factorial 3, this is 18, and x minus 2 4 by factorial 4, this is 24. This is the expansion of fx at the point x equal to 2 by Taylor's theorem.
Sir, the last time we should not write x naught, no sir. We should write c, means we will not get there after upper 4. The last time should be, we should write c, no sir. And you told x not equal to 2, but c is not equal to 2 now.
If we consider this equation,
Sir, one more dot in.
okay, okay, okay.
Hello.
Okay. If you write,
Sir,
if you consider f is a function of f is a polynomial of degree m, in that case, what will happen? If you consider function is a polynomial of degree m, in that case remainder will be 0,
0. Yeah.
right?
Yes, sir.
Okay. You got the point now?
Sir, note 2. Note 2 point में some dot.
Not 2.
Note 2.
Say.
Sir, f of b equal to f of a plus b minus a into f dash a. It is cancel. How it is cancel out? Cancel या erase. What does it mean? I can't understand. F of b equal to f of a plus b minus a into f dash a. Second line, sir.
Second line.
Yes, sir.
F of a plus, this is
No.
This is-
F of this line. F of b equal to f of a plus b minus a into f dash a.
this line.
No. Sir, f of x के below में एक line है f of b लिखा हुआ.
This
सर
is
f
not,
of x जो फंक्शन है f of x लिखे हैं उसके नीचे में जस्ट f of b है.
और
वो गलत है यार.
ये वाला,
वो
ये वाला,
गलत इरेज किया हुआ है सर.
ये वाला, ये तो
Yes,
गलत
sir.
है, ये वाला गलत है.
अच्छा, function is right ना. The
हाँ.
written the function is written inside the. This is
It's
right.
not.
Wrong. It is
This is
also
wrong.
wrong.
This is wrong.
Okay.
Okay. If
Sir, there you mentioned m is greater than n, sir. But here n we don't know, no, sir. In this case.
in this case, actually, f is a function of a
Polynomial.
finite order. So remainder term will be 0 there. Okay. Find nth Taylor expansion.
Hello, sir.
Ah,
Sir, in the question it is asked, we should write the answer in terms of x minus 2's power, right?
x minus 2, yes.
Yeah, but we are getting x minus 2 into some another polynomial which cannot be written in x minus 2 power, sir.
X minus 2, all are the coefficient.
Okay, sir. Fine.
The coefficient that is the constant. Find the nth order Taylor expansion of ln 1 plus x about x equal to 0 for x belongs to minus 1 to 1. Now do it.
After ln of 1 plus x,
ln 1 plus x.
this is what almost.
Sorry, sir. What was written after ln x plus 1?
ln 1 plus x about x equal to 0.
This is about, okay.
Okay. Now in that case, this is not a polynomial of finite order. Okay. In that case, we get the remainder term. Okay. In that case, we get the remainder term. What will be the remainder term? First, you have to find f dash x, that is derivative 1 plus x, f double dash x minus 1 plus x square, f3x, that is minus 1 square by factorial 2, 1 plus x cube, and so on, and fnx. Fnx will be minus 1 to the power n minus 1 factorial by 1 plus x to the power n. So f dash 0, that is f dash x at the point 0, that will be 1. F double dash 0, that will be minus 1. F triple dash 0, it will be 2. And fn 0, that will be minus 1 to the power n minus 1 factorial. Now apply Taylor's theorem. So ln 1 plus x, that will be equal to, just put the formula and the derivative of f dash 0, f double dash 0, all we get actually x minus x square by 2 plus x cube by 3 minus x4 by 4, and this terms minus 1 to the power n minus 1 x to the power n by n, not factorial n, okay? All factorial will cancel, and this we get 3 4 dot 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 n, and this now we get the remainder term. Remainder term will be minus 1 to the power n factorial x to the power now here 1 plus c to the power n plus 1. This is the remainder term. Okay, in that case we got the remainder term. Okay. Next, more examples on Taylor series we discuss in our next class. Okay, thank you for this class, and
Sir, please share the PDF of this notes, please.
Okay.
Sir,
Hello.
means log 1 plus x expansion is this with general little x minus x square by 2 plus x cube by 3, no sir. Means we should give at x equal to 0, then only we should tell. General also we tell the same expansion, no sir. No,
General expansion we get actually from Taylor series expansion.
Yes, sir. But we have condition at x equal to 0, no, sir. But if we change at x equal to 0.5,
Okay.
the
General expansion, actually the Taylor series expansion at x equal to 0. This is the general expression. Okay. This is the general expression. Actually, Taylor series expansion at x equal to 0, that is called the Maclaurin's expansion. And that is the general expansion of log ln 1 plus x or sin x or cos x or anything. This is the general expression. Actually, the remainder, all the remainder term for general expression, this is a infinite order expansion,
yes, sir.
right? That is not finite. That is infinite in general expression, right?
Yes, sir.
But in that case, Taylor series expansion, that is finite.
Yes, sir. I also another doubt, sir. Why Tyler stopped with the remainder 1, sir? We have other remainders also, no, sir. Means R2, R3 also we get, no, sir. Like infinite expansion. But Tyler stopped with R1, Rn plus 1, no, sir.
R n plus 1.
Why, sir, like that? We stopped.
Rn plus 1, if we put n 2, we get the remainder. If n equal to 1, 2, 3, dot, dot, dot. If we extend the n up to infinity, the remainder will be 0. We have to, if we increase the value of n, the remainder term will decrease. If we expand the n up to infinity, the remainder term will decrease to 0. Okay, then in that case, we get the actual value of L in ln of 1 plus actual value. Not
Yes,
actual value, approximate value, but closely near to actual value. Okay.
yes, sir.
Okay, thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank